I'm Flavien, the CEO of Pandascore, and I won't talk about football, even though I'm pretty happy about the result yesterday. But I'm going to talk about something new, something more exciting, esports. And the angle I want to talk about is how we've worked with our data scientists to optimize and to help them do a better job, be more efficient, and be more happy with what they're doing. But first, I want to explain a bit what we're doing, and I think esports is a big part of the equation. So basically, we're all used to watch people running after a ball. Now we watch people running after a mouse, but like a physical mouse. They are playing games, but they're playing games professionally. So the two guys you see on the left, Frozen and Tom 60 whatever, those two guys, they are professional players of Hearthstone. Hearthstone is a game of cards. It's basically poker, but with more than thousands of different cards. And those guys are paid to play. They're watched by a lot of people. And there is a lot of different esports. This is League of Legends. This is one of the most famous one. So this game, there is more than 100 million people playing the game every month. And what's more interesting is not people playing, actually. It's people watching. And those guys are they're as excited as I were yesterday evening, maybe more. And basically, the fan community is what makes esports interesting. There is more than 200 million people watching esports on a daily basis, on a monthly basis. And that create an ecosystem around esports, because there is a lot of fans to monetize in a way. So everything you imagine for traditional sports, for football, for example, it's exactly the same for esports. The structure is the same, meaning that all the companies you can expect in sports, they are in esports. So there is professional teams, there is psychologists, there is sponsors, there is media, TVs, there is bookmakers on esports. So you can bet on people playing video games. That exists. And one of the interesting things is, exactly like in sports, those guys, they need to monetize the audience. And one of the key resource is data and statistics. Bookmakers, for example, they need statistics to build odds. Professional teams, the coaching staff is supposed to monitor the performance of the players, and so on and so forth. So that's what we do. Pandascore is an esports data provider and odds provider. Our role is to provide to the ecosystem as a whole statistics about what's happening in the game, in whatever game, actually. And the question is, why we need AI for this? It's a good question. For the moment, just to give you a sum up about the company, we are around 25 people, and we have 10 people working in AI, 8 data scientists, 6 engineers, 2 PhDs, and people, DevOps, working to help them in AI. And so why we need it? Basically, there is a lot of reason why we don't have any alternatives. For example, we could work with developers, but they don't have access to data because most of the competition are hosted on private servers. We could work with tournament organizers, but there is hundreds, if not thousands, of different tournament organizers, so doing partnership is not very optimal. And manual data collection, of course, it doesn't really work. So while we're using computer vision, basically every competition is streamed. So we have a huge amount of live video resource. There is a lot of different statistics to collect, way more than what you have in traditional sports. And I will show you some examples right after. And most importantly, in sports, in esports, the same constraints apply. It's all about live statistics. So you want to know if there is a goal half a second after the goal really happened. And esports is the same. If there is a team fight, you want to know who won the team fight few milliseconds after it happens. So when you want to collect hundreds of data points, doing it manually, it's impossible, so you need to use AI, or computer vision, more precisely. So this is an example of what we're doing. So this is the minimap of League of Legends. This is a small part, the small piece of the actual interface. And you can see a lot of icons moving around, and there is some blue or red color on top of it. So basically, our algorithm is predicting the localization of every player, the coordinates of every player's real time. And so the blue and the red one is our algorithm to put in. And we're using like a different, every kind of statistics has a different approach. And the approach for this was using GAN for data set augmentation, because it's very hard to collect data for this. Coordinate is very hard to have data sets, and also the champions. So basically it's an avatar, and there is 120 avatars in League of Legends, so there is a lot of different ones. And also every few weeks there is a new one coming, so you cannot just have one network that works. You need to re-implement the solution, the retraining again and again. So we decided to have some kind of an automatic way to create data sets, and then we use Conval STM to do tracking on those different icons. But this is just one of the example. To give you a better look, this is League of Legends, and all the red area you see are different kind of statistics we can collect. So there is more than 200 data points, different data points to collect real time. So every kind of scenario is a different models, or can be different models. There is icons, there is images, there is movements, there is just basic figures and letters. There's a lot of different examples. And that's one of the big challenge we have, is being able to collect all of this real time. And real time is a matter of milliseconds. So this is the key thing in the company, the key value in the company is the architecture we've built to analyze this. It's not just data scientists working in their computer and doing their stuff. It's about putting this in production and having a reliable way of providing data to customers. So we've built some kind of a software architecture we call Panda Vision. It's pretty obvious for us, and basically this architecture is taking the work of data scientists, so they work on different kind of models. It can be detection, it can be tracking, it can be whatever you want, and we have some kind of library for this with hundreds of different ones, and then we apply the technology and we create instance for one game, for League of Legends, for one specific match, and you just take whatever algorithm we need, and those algorithms are processed. And the interesting thing is, very early on we decided to put everything in containers, in Docker containers, to have a very scalable way, very replicable way to analyze hundreds of matches, because obviously, like sports, there is a lot of matches ongoing at the same time. So the technology, the architecture is the basis for the company, and it's what allows us to scale the volume of match we can treat, we can analyze, and also the work of data scientists, because they can work, like we can have 20 data scientists working at the same time. But obviously, when you work with data science and in AI in general, there's a lot of different challenges that you don't have everywhere else, or specifically in the developer sphere. I will try to explain a few challenges, and then I will try to propose some solution we implemented. But obviously, our solution works for us, and sometimes they don't work perfectly, so we're still a work in progress. But the solution cannot be applied. It's just how we do it, and we'll be very happy to have the chats with you if you have some advice or even feedback. So the first thing is the product ownership. Often the data scientists are working on a model, and they can be very focused about this, and they often not see the big picture, and meaning the product in itself, because they're pretty far away on the chain. So basically, in our company, data scientists are the first step for us. They create the statistics, then we build predictive model like odds, and then we provide them into an API, and then we have the customer in the end. So they're pretty far on the chain. So they kind of feel disconnected or feeling less motivated about what they're doing. Second thing is research and development. The way we work is basically we ask them, okay, you have these statistics. So you have the minimap, for example, the one I showed you. You have to track the players. You have to have 99.99% of accuracy, and your process should take 25 milliseconds. That's the constraint we give to the data scientist. And the guy doesn't really know how he's going to do it, if it's going to take 10 weeks, 20 weeks, 5 weeks, and also if he's able to make it through the different constraints and different metrics we impose to him. So it can be very hard for, as a data scientist, to get motivated, to have the key goal. And also, as a business, it's very difficult to understand, okay, this is the deadline we need to have, because it's still research and development, even though if it's very applied. Another topic is the performance assessments. It's quite hard to find, to put key metrics and to understand if it's 99.99 or 99.95. The details is very hard to understand. And also, it's hard to follow the evolution of the performance. For example, if we have a model predicting the coordinates, if it takes, like, for example, we launch it, and then 3 months after, how are we sure that the model is still performing well? Because they might have some evolution on the videos which we're analyzing, they might have new champions we didn't predict, stuff like that. So the pipeline to following and tracking all the performance of the different statistics, because we have hundreds of them, it's quite a challenge. And finally, one of the biggest challenge, I think, is data sets. It's so hard, it's so boring, and still data scientists kind of has to do it. And that's like huge loss of productivity for data scientists. So I've talked about some challenges, and when I'm looking at those challenges, there is a few stuff that strikes me. The first one is there is a huge topic around the organizational and motivational structure. So how we make data scientists work and how we motivate data scientists to work. Second big topic is experimentation. And the last topic is deployments, putting in production what you're doing. So I'm going to go a bit deeper in those different topics. The first one is the motivation. It's pretty straightforward and nothing like rocket science here, but it's trying to find a way to incentivize and to make the data scientists very close to the product, even in terms of feedback loop. How can customers directly chat or can directly give feedback to our data scientists to improve the models? And one of the way we explore was trying to learn to teach the data scientists the few basic of the game, and way more than just the basic. Because our data scientists, they don't know each game. They cannot know every game. It's impossible. So we make them play the game. We force them to play the game. So it's probably the only job in the world where you're forced to play, and you paid for this, and you're not a tester. So we force them to play games. We ask them to watch the game. We also make them chat with professional players to explain, okay, these statistics, it might evolve this way. Sometimes you have a hard scenario or unpredictable one and stuff like that. And also, at Pandascore, we don't talk about model ever. We talk about statistic. You work on a statistic, you don't work on a model. Model is a mean, but the reality is you work on a statistic. The workflow. This is a bit of a shameful slide. Basically, I've never heard of Scrum in my life, or I've heard the name, but I never knew what it was exactly. So when I was starting to figure out how we make our team of 8 data scientists work on AI, I was like, okay, how we do it? And then I came up with some guidelines and some ideas with the team, and it's kind of feel like Scrum. It's kind of different, but still there is some common topic. But the first thing is we work with Rush. Rush is more esports friendly than Sprint. I think it's Sprint. It's for those who play Counter-Strike, it's Rush B, for example, but it's very nerdy-ish. So we work with Rush 5 weeks. It allows us to have enough time to experiment, but at the same time, it's not too long to have like a roadmap for a few months. When you are the startup, you have to go very, very fast and to iterate very fast on the new models you're shipping for your statistics. We have a backlog driven by customers, and that's very, very important. What we develop is for customers. So we have the queries from the customers. We also have some statistics that allow other statistics. And this is driven by 3 different scales. So every time we have a query from customers, we say, okay, is it priority, a high priority or not? Is it fun? And is it complex? And those 3 scales are very important because it allows us to understand and to okay, this data scientist is working only on complex stuff because he's a PhD, he has a lot of experience, but sometimes you want to also give something complex to a junior data scientist to make him improve. So it's about balance, and also there is a lot of models that are not very fun to develop, and statistics are not very fun to develop. So we try to give one depending on those scales. Also experimentation, and that's very different with whatever model you have, but in Scrum or whatever, you don't really fail. You fail to meet the deadlines, but you don't really fail the task, or it's very rare. And because it's mainly because you're not good enough or experienced enough. But in AI or in data science in general, sometimes you cannot achieve the goal. It's too complex to have a 99.99% of accuracy for some examples. So this, as a key value, we understand that it can happen. Another thing is the maintenance of the models. So there is like probably 20-30% of the work of a data scientist in our company linked to maintaining the models, because there is updates on the game, because there is new quality of the video stream that we didn't have in the past. So there is a lot of maintenance to be done. So that's pretty much how we work. Obviously, it's way more complex than this, but it's just an overlook. The second big part is experimentation. So it's a big part of the job. Like the data scientists at Pandascore, they work 90% of the time on experimenting. So there is different steps I wanted to sum up here, and it's pretty obvious the steps, but there is the creation of small data sets to test multiple approaches. Then you choose one, the best one, then you create a larger data sets, then you have an iteration process where you want to do model tuning, and you retrain, model tuning, retrain, and then you deploy and track the performance. And it's a cycle because there is maintenance, so you always have to redo the cycle. When you look at this, there is two different area where I think you could improve the work of data scientists. The first one is the most obvious one, is the creation of data sets. So we use data operators, and we don't outsource the data operation. We decided to have it internally for agility reason. It's way more expensive, obviously, but like we can do better data set, we can do faster them, and we don't lose so much time to create some kind of a PDF that explains what kind of data you want, stuff like that. So we go way faster with this strategy, I would say. And the other area is experimentation. In itself, there is two different top areas there. There is the testing multiple approaches and the iterating on the model tuning. We decided to develop some kind of a software. It's called XP Runner, so it's to run experience. It's pretty obvious also. And this is basically, there are two sides of the software. There is a software side and there is a library side. Basically, the library is a bunch of models. So we have around 10 different model architecture that we can use. And there is the software side that kind of selects the model. And basically, it abstracts all the complexity of the scripting work, and it's put everything in one location, so you can work on a lot of different models, and you can test automatically a lot of different models. So you say, okay, I want to test on this model, this model, this model. The software is testing everything, and it basically says at the end which one is better, so you can plot a lot of the different features. One of the interesting thing is also you can go deeper for, if you have one model you want to test deeper, you can do testing hyperparameters, tuning, so you can just ask the software to test these parameters with specific value in a range. So it's very efficient to help the data scientist experiments. And also the good thing is data scientists are experimenting way more with these software than they were in the past. So they kind of create an intuition on how one model could work with these kind of parameters and so on and so forth. So it's also a way to scale up the experience of our data science team. And the last thing about XP Runner is it's pretty great to work like in the long run. So there's a lot of maintenance to do on our side. So we use back like past models, and we have to improve them. So basically everything is saved. Every model parameters are saved in a database, and every model is saved also. So we can very easily fetch back another model to reuse it, retrain it, re-implement it. And the last thing I wanted to talk about, it's very dev on a way, but it's a big challenge for AI company, is how do you deploy and how do you make sure that your experimentation are not deployed in production too fast. And we had some example of very, 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 very low accuracy model that went into production a bit too early. And basically the way we work is using Git, so we Git everything. And basically we have three different environments, the development environment, so it's just about experimenting, the testing environment called the staging, and then the production environment, it's about the real stuff. And we have different process to go from one another. So basically every experimentation is done on the first environment. When we're pretty satisfied about the accuracy or the performance of the statistic. We have merge requests, we do code review, and then we merge it with the staging environments, and then we can test actually in real world, because the staging is exactly the same as production. So basically it's just a fake Pandascore, I would say, simplify. And when we test for a bunch of days, from 1 week to 2 weeks, and in the real world, so we have people monitoring, the data science guys are monitoring the statistics, and at the end, if we're satisfied, we push it in production. And obviously this process can be quite long, it can be 2 weeks, for example. So if you have a huge problem in the production, you can just hotfix this and get rid of all the work and put something in production that doesn't work. So basically, those are the three main things I wanted to talk about. It's pretty, I was pretty fast on explaining this, and if you want to chat more about this, I would be very happy. So thanks everyone, and have a great evening.
Okay, we're going to start with a question. Please feel free. Perhaps someone can. I'm going to give you one.
I'm just the CEO. I don't no technical stuff. You can go technical.
Well, first, I was really impressed to see how organized you are. For I don't know how many years you've been building it. It's really well organized, and I'm pretty sure that a lot of things that you've done could be applied for many other businesses that are working on AI and even aware. But well, it's a bit technical. But I just wanted to know concerning. I mean, there's a lot of new things popping up in games, and currently, I mean, when we talk about AI, we think a lot about neural networks, which needs things that are massive data and things that we've seen already. So how do you combine? I suppose that you not only use neural networks, I suppose you use also algorithm. I don't know if you Bayesian networks or things. How do you combine those, and how even do you manage to make them all work together?
The first thing is, I think, is education. So we need our data science team to be very well aware of what exists and what would be maybe the best solution to work on. So we do use classical computer vision algorithm, we do use neural networks, we do use Bayesian improvers, we do a lot of different stuff. So education is the first thing, and we have, for example, every Friday morning we have the paper club, so we present a paper, and this is the kind of stuff that kind of open mind everyone in the company. That's the first thing. The second thing is the architecture I've showed you at the beginning. The way we want it to work is all Docker containers. And the containers are working with each other, so it's very easy to have one algorithm that gives data to another independent way, and then everything works magically. But it's kind of complex to do. But that's the way we wanted to do it, because there is so many different examples, and sometimes very basic algorithms. So we're using, for example, Tesseract or CR sometimes. It's pretty slow, so that's one of the reasons we don't like it, but sometimes it works very well. And we have other examples of so many different networks. So we needed to have something very agnostic of what you put inside, what kind of models or what kind of algorithm you put inside. It works for everything, basically.
So basically, do you, when you launch a new game, the learning curve from your data scientist, can you go faster? After months, you have really increased the process, and you seem very tough in that. But can you rely on their experience and say, okay, if we have to launch, I don't know, perhaps 5 new games, we're pretty sure that we're going to do it with this matter of time?
I think the first thing is, obviously, the more the scientists work, the more they experiment, the better they are. So that's the first thing, but it's not the one you can really play around. The second thing is, there is some algorithm that works on any games. For example, we've developed our own OCR technology, so optical character recognition. So basically, this works on League of Legends, this works on Dota 2, this works on Overwatch, on whatever game. And the way we've done the tool, the software XP Runner, it allows to plug new models every time. So we can use those model architecture to a lot of different use cases. So we are going faster, of course. And the DevOps approach is helping us to go faster. And I think it's part of the thing we want to keep pushing around, because I think there is so many things we can do with DevOps and improving the data scientist's job, because every game is different in the end. So we will have to redo stuff. It's 100%. So we need to be faster in terms of process, in terms of where we experiment, and in terms of accuracy.
So 3 parts: infrastructure, persistence, and scale. What is the infrastructure you're using? Is it your own infrastructure or using AWS? For your persistence layer, how are you calling up your models, and how do you scale your models when you have multiple League of Legends games going on at the same time?
Okay. The first question is, what kind of infrastructure are we using? We're using both cloud and bare metal, but mostly cloud for the moment. We have our own server in the company, but it's mainly made for experimentation. And we use cloud because for the moment we're small, and we need to go fast, and also we have customers in China, so we need to have clouds there. We have customers in America, we have customers there, Europe, stuff like that. We use Google, but we have used AWS and we have used Microsoft, everyone. So we tested everyone. And the second question was about the scaling of the models. I won't go in this much into details, and it's not because I don't want to. It's just because it's very, very specific. And the other question was scaling. We use our own custom orchestrator for good and bad reasons. But the good reason is we use it for custom specific reason we have due to our product and to the quickness of our product, because Kubernetes is pretty heavy compared to what we have. We develop ourselves. But we could use Kubernetes to do it. Everything is Dockerized, so we can do whatever we want, Swarm or whatever.
Hi, I'm Aditya. My question is on the business side.
Yep.
So how competitive is the space? How do you reach your customers, and do they pay you to run business? Like, how do you monetize it?
We don't do revenue. Revenue is overrated. We prefer to do research. It's better.
That's
good. So basically, the competition in the industry is not so big. The first reason is the ecosystem is not so developed in terms of cash. So basically, the only kind of customers we can make a lot of money with is bookmakers, because the team's too small. The media, they don't have money. There's a lot of different reasons for this. So it's an early market. So we are also very early. Like, it's been 2.5 years of working on this. So we're pretty early stage still, and we're basing a lot on the technology we've developed. And the way we work is API. So we just have an API. You can test it. api.pandascore.co if you want. We can even give you a free trial if you ask nicely. And basically, it's just the customers, they just use our product and they build whatever they want. And we have a lot of different startups using our products. Like in Asia, we have fantasy websites. We have new experience for betting. We have score apps. We work with TV. We work with Canal+. We work with L'Equipe. We work with PMU. We work with Paris Saint-Germain also. There's a lot of different kind of use cases, basically.
One last question, but Flavien is staying with us before going to the match, so we'll be having a beer with him and talk about esports, please.
So it's actually 2 questions. The first would be, you said about the data scientists, you don't want to outsource the data annotation.
Yeah.
Did you occur, or why don't you use like specific people to do the data annotation if it bores the data scientists?
Okay, I was not clear. We use specific people to do this.
Okay.
The data scientists are not doing data annotation. They're only doing the small data sets because they just need to annotate like hundreds images. But we use people internally, or data operators, and they basically the work they have is first creating data sets, but it's also monitoring the performance of whatever statistics in time, and trying to find some errors, because there's a lot of patterns of errors in what we're doing.
Yeah, and the second question was, in those kind of games, there's usually changes of layouts depending on the competition or whatever, and it can really change the image. How much of the old data can you reuse, and how do you manage to keep up when there's a new layout for a new competition that didn't exist before?
Okay, so we can use a lot of the previous data, because, for example, for the OCR networks, we use a lot of different figures and letters in the games. For the images, they might change. But what happens usually is there is 1-2 champions that change the image, but the rest are pretty much the same. So we don't have to redo everything. In terms of layouts, it was a huge issue at the beginning. We were doing the layouts manually, so we have like a grid. It was pretty funny. And so when we have like a change of layouts, we were never noticed by the tournament organizers or the video platform. So we had to do it, and we basically lost every time an hour to do the zoning. And so we decided to use more detection algorithm to understand the interface. But sometimes there is huge changes, but those changes are documented usually. Like small changes, they can happen whenever. Sorry, they can happen whenever. But like the small changes, like the huge changes, they happen and they warn us. Like they have like the huge patch release and they say, okay, this layout is going to be completely changed, blah blah blah. But sometimes we can get screwed because they just suppress one statistic. Like it happens a few times. It's pretty rare because they don't want to suppress the experience of a viewer, but sometimes it might happen.